All right, we're live. Thank you everybody for joining us. Today we're going to talk about the differences between triple equals and double equals. With me, I'm Justin Meyer, and with me is Julia from DC.
Hey guys.
Alexis couldn't join us today. I actually don't know why. I think he's on PTO, but I couldn't get a hold of him, and Julia nicely stepped in. If you have any questions, again, just write them up on the Bitovi JS training Gitter. I'm going to get into the presentation. So yep, if it's Wednesday, it's Bitovi JavaScript training day. Again, our goal is to, by the end of the year, go through all the basics of JavaScript jQuery and application level front-end development so that people can pretty much build anything they want in JavaScript. My name is Justin Meyer. I am the CEO of Bitovi, and I will be doing the vast majority of these trainings. And the format, it will typically be a lecture, exercises, which there are no exercises for this training or the next one, but I think we start having them after that. Ask questions at any time through our chat room, which is at Gitter IM Bitovi JS training. And at the end of this one's a short one, and at the end of every training for the last like 10-15 minutes, I will hang around and answer any front-end related questions that people might have. So as I said earlier, today we're talking about the differences between triple equal and double equal. I think this is one of the most common confusions that people have, because it's weird that JavaScript has two different ways of comparing if things are equal. And this week is brought to you by SteelJS. SteelJS is Bitovi's dependency management solution. You can find it at steeljs.com. If you're looking for something like Require.js or Webpack, but better, because I can talk about real briefly why it's better. You can use SteelJS for dependency management. It can load any type of module. It can do very fast production builds. It can load from Bower or from NPM. And you can also use it to export your projects into any of the very commonly used formats. So SteelJS. All right, back to the training. So before we talk about the differences between double and triple equal, let's show why it can be a little bit confusing, even though I feel like Julia will probably know the answers to all of these because she's seen this slide before. Julia, what do you think? What is 21 double equal to the string 21? Are those two things equal, double equal?
Yes.
They are. Is undefined double equal to null?
I don't know.
Take a guess.
Yes. No.
No.
False.
They are. Good. You're proving exactly why this stuff is confusing. Is undefined triple equal to null?
No.
No. Is 21 triple equal to 21?
Yes.
Is an object triple equal to another object?
False.
Is not a number triple equal to not a number?
True.
You would think true. I feel like this one should be true, but no, it's false, confusingly. I think this is for like mathematic reasons.
Okay.
And then is true equal to an object with a value of property that is a function that returns the string 1?
Yes.
It is. Awesome. So yeah, like I said, double equal and triple equal can be pretty confusing, but I think that this presentation will hopefully clear it up. for all but the weirdest cases, which is like not a number, triple equal, not a number. So triple equal with primitives, you can think of as doing a bitwise comparison. So if you remember back from our previous presentation where we had, we were creating strings in memory. So we'll have, here's stir1's string, and here's stir2's string, and the call object has the variables kind of pointing to the memory addresses of where their data is. And just do a bitwise comparison. So if the types match, then it's just going to kind of look through all of the other data, the actual bytes in memory, and see that stir1 is triple equal to stir2. Now, if you looked at triple equal with objects, here we've got object 1 is an object in memory. So we have our object in memory, and object 1 variable points at that, and we have another object in memory, and object 2 points at that. Well, you can see these two objects look the same in physical memory, but they're not triple equal to each other, because with object types, anything that are not primitives, it's just going to compare the memory address. So it's going to compare, does 2001, is that equal to 2101? And because they're not, triple equal is not true. So you might already be able to tell that, well, in order to do this, it's got to actually check the types and make sure that the types are object types, and then do the comparison. So it does kind of have to dereference these pointers to get to the actual, where the actual data is in physical memory. But once it has the type, it just compares the pointer addresses, or does a binary comparison, or bitwise comparison if they're primitives. Oops, let me kill my notifications. Okay. So now let's talk about how double equal works. Double equal uses this very complex decision tree to determine if two values are double equal to each other. So these are all the steps of the decision tree, kind of the questions it asks, and the arrows kind of take it, depending on the true, if it's true or false, it kind of does some transformation to one of the values on either side of the equals, and then kind of sometimes repeats the same process. So to better understand this decision tree, let's walk through an example. So here, I'm going to do true is double equal to an object with a toString property that is a function that returns a string with the string that has 1 inside of it. So let's walk through what double equal does. First thing it does checks are the types the same? In this case, they're not the same. One's a Boolean, the other's an object. Are both null or undefined? No. Not. Is one a string compared to a number? No, this is a Boolean compared to an object. Is this a Boolean compared to anything? Well, yes, this is. This is a Boolean compared to an object. So what it's going to do is take that Boolean side of the expression or is this a statement? Let's say expression. Can't remember the difference off the top of my head. Julia, do you know the difference between expression and statement?
Putting me on the spot.
I'm on the spot too. I don't know the difference actually off the top of my head. I think a statement is like, I think an expression is like kind of can mutate data, and an expression is more just like for retrieval, but I very well could be wrong about that. I'll look this up at the end of this talk and do my best to explain it. So anyways, it's going to take this Boolean. I think the whole thing is a statement, and Boolean is this can be an expression. Anyways, it's going to take the Boolean and put it through this transformation block here. So it's going to take the true, and it's going to say, hey, convert the true to a number. If the Boolean was false, it converted it to 0. True gets converted to 1. So, and then it's going to repeat the, let me move my Hangout, which is, there we go. It's going to repeat double equals, but now with the number 1 compared to the same object we were comparing before. So, okay, now that's back up the top. It's going to go through the same questions. Are the types the same? No. Both null or undefined? No. Is a string compared to a number? No. Is a Boolean compared to anything? No. Is it an object compared to a string or number? Well, yes, it is an object, and it is compared to a number. So what that's going to do is try to take either the toString or the value of the object. It's going to call either the toString method or the value of method on this object and get out whatever it returns. In this case, it's going to be 1 is double equal to the string 1. So it's going to repeat again. 1 double equal to 1, string 1. Are the types the same? No. Both null or undefined? No. Is a string compared to a number? Why, yes, it is. Then it's going to take the string and try to convert it to essentially a number. So if the value it's trying to transform is a string, it's going to try to essentially do, you could think of it as like a parse float. It's going to try to convert that to a number. In this case, it's going to convert that to 1. Then finally, are types the same? Yes, they are. Use triple equal to compare. That's why the thing we originally are comparing, true is equal to toString that returns the string 1. That's why it's true, because eventually it converts the left-hand side to 1, converts the right-hand side to the string 1, and it converts the right-hand side to the number 1, and then finally does triple equals on those, getting true. Intense. So in summary, triple equal, this is what triple equal does. It first checks if the type are the same, if the types are the same. If the types are not the same, then it's false. If it's a Boolean compared to string, it's false. Then it checks is the type, because the types are the same, is it a primitive, are the types a primitive? Is it strings compared to strings or Booleans compared to Booleans? If they are primitive, it's going to do a bitwise comparison. If it's not primitive, it's just going to compare the pointer addresses, essentially. And if those are equal, then it's triple equal. Those are not, then it's false. So for object types, it does address comparison. And then the summary for double equal is really that type coercion craziness. It's complex and weird, and that's why the only time I ever really use double equal is for null compared to undefined. Like if I want to know if a value is either null or undefined, I'll use double equal, because that's a great way of checking both cases. Otherwise, I stick to triple equal. So that's kind of my rule of thumb, is triple equal everywhere, double equal except where you want to compare something. You want to handle if the case is null or undefined with one kind of easy step. I'll use double equal. So that's the lecture for today. It was a short one. Next week, we're doing a really important one, which is closures. So now Julie and I are available for questions if anybody has any. Just fire it up in Gitter. And if not, then we'll bid you guys adieu, but we'll hang out for like 10 minutes and see if anybody has any questions. So Julie, did this make a little bit more sense on the second go round to you?
Yeah, I mean, it was a good refresher on the topic. It's always the null or undefined. I think that tripped me up. And then also that empty. Would always get confused because like empty strings are false, evaluate to false, and then empty arrays evaluate to true. But that's not really double equal versus triple equal.
No, but that, I mean, it's falsy because I think an empty string like goes through this box and then comes out falsy.
Yeah.
I don't think it comes out not a number. That would be interesting. But nothing is actually equal to not a number. So the way that actually, so it must come out as the empty string must come through this box and come out as false. That's the only way I can think that that actually works. Because if it came out as not a number, well, then nothing, you can, false would not be triple equal to not a number. Well, it would take Boolean compared to anything. It'd take the Boolean and make it 1 or 0, and then it would be not a number is equal to 1 or 0, types the same. Yes, they would be. So that's the only way I can kind of see that working. Interesting. Yeah, I think that it's kind of weird that JavaScript has both. It seems like double equals just isn't that useful in the end. I mean, it's nice for string compared to number, but I think I'm surprised it just didn't make the developer just go through the little bit of effort of type coercing the number to a string themselves. Do you know how to type coerce numbers?
To a string?
Yeah, what are some good ways of doing that?
I mean, one way would just be adding an empty string to the number. That's my lazy way of doing it.
Lazy way of doing it? Let's check, do the console. So what we're talking about is like, you know, sometimes you want, right, JavaScript lets you do this. I can compare the string 1 to 1. But I feel like it's, you know, like I said, it's much better to always use triple equal, but sometimes then you want to actually convert this to a number. So what did you say was your lazy way of doing it?
Well, so
those are true, but what if you wanted to convert the string to a number?
I think you can subtract 0 from it also would be.
Does that work? I've never actually tried it that way. Weird.
Yeah.
I did not actually know that. Huh. The way that I always do it is you can add plus in front.
Okay.
And that type coerces. So RJ Smith just asked, so it's always better to use triple equal instead of double equal. Well, it's definitely going to be more performant to use triple equal instead of double equal. Like I was saying before, the one place that I'll use it is if you have, I'll use it in, let's say, like, I wanted to know if something is null or undefined. So I might have some code that's like, I don't know what this is doing, but if it's like, if some value came in here, let me actually increase the font size. So if some value is double equal to null, this is a good way of saying that if value is null or undefined, run this code in here. I have this check. So this is a really this is the one place where I will use a lot of double equal. If I want to see if something's strictly null or undefined, I'll do this. So I can run my check function. So value is null or undefined. I can put in null. I can put in undefined. But if I put in things like 0, things that are kind of considered falsy by JavaScript, I don't get, you know, this console log value is null or undefined. So this is the one place where I think double equal is very useful, but otherwise I use triple equal.
Yeah.
Another way of, I think though, does plus, if you do 0.1, does plus convert that to, okay. So what about using plus? What do you mean? Is it better than parseInt or number or just equivalent? So parseInt, I'm not actually sure what, like, I've never actually used number to do. My guess is that's probably roughly equivalent, the type coercion that plus does. But parseInt is a little bit different because parseInt, if I give parseInt something like 2px, that's going to give me 2 back. But if I did something like plus 2px, that's going to give me not a number back. But also, if you do stuff like parseInt 0, 0, 1, or what's a radix, weird radix example? I forgot how to force, because I was just passing the 10 because I've to radix, the base in mathematical. So parseInt, you always want to provide the radix, but I'm trying to, does it default to, there's some way of like making it, does 101? No. Or is it just because if like you start with like A? No. What is the default radix? Oh, different implementations produce different results when a radix is not specified. It's possible that Chrome is putting a radix of 10, but maybe there's different browsers then that use different radix, and that's why I'm not seeing it. But like what you could provide is like a 16. If your browser, if a browser defaulted to having a radix of 16, then let me try that one. 0. Yeah, that my first 0, 1 should have probably, but 0, 1, 0, 1. Let me try that. Yeah, you still get what you would expect, but if it was treating that as a radix of 16, then you would get 257 back. I bet Chrome always by default does what's sane and uses a radix of 10, but other systems will not use that. So yeah, you can use parseInt to, what Lindsay said, to convert between different bases. Yeah, that's exactly what it's there for. But it's nice also, I think, sometimes just because it can convert. You know, sometimes if I know I'm getting, I'm reading like a CSS property of the DOM, and it's going to give me that as 2px or some other kind of like EM or some kind of additional thing, and I want to be lazy and not have to parse that off. I'll use parseInt 10 to get that 2 pixels. I wish it kind of did this with things before. It does handle space before, but it doesn't handle like any characters before. But this can be a very nice, cheap way of getting a number if it's followed, if you know it's a number followed by some kind of unit. Oh, there we go. Julie provided a nice reference here.
So it looks like if it's like 0, 8, I don't know.
Okay, so I wonder, does it have like a list? I wonder if it has a list of browsers that. So it's good that ECMAScript 5. It's forbidden by ECMAScript 5. So leading 0 does not put it into octal. All right. Yes. That's a good point. Zerk said that 35 or 34, 45, 66 will not give you, will not like, remove, ignore. Well, it kind of any spaces. Once you have essentially contiguous numbers, any spaces past that point are just, and any characters after that point are just ignored. So we can try, but things like this I think do work, although it does parse int. There's a parse float. You want to use if you're going to get floating point numbers, it does the same kind of ignoring. I don't think any kind of weird comma would help. Yeah, I think you could put commas before. Maybe not. Let's try. For sure, actually, probably can't. Okay, you get 12. Yeah. So really, it's just looking for. Let's see if I do multiple dots. Oh, that's interesting. Oh, well, actually, no, it's not. So it's kind of looking for the first decimal or first digits followed by decimal followed by digits, and then anything else it just ignores. Yeah, it just basically stops processing and looking for a number, I assume. Yeah, Lindsay, I think that's what it does. Cool. So any other, if there's no other questions related to triple equal or double equal operator, I think Julia and I are going to take off. Next week, though, is going to be a really good week. It's closures. I think a lot of people have questions about that, and we'll do a lot of examples there. So I hope I see you guys all next week. And until then, Alexis and I check the Alexa, or let me actually share myself. Here we go. Hey, so Alexis and I actually do check the JS training chat room like over the course of the week. So if you guys have questions there, please post them and we will answer them at the next session. So until next week, thank you guys for joining. And thank you, Julia, for stopping by. And see you guys next week.
Have a good week. Bye.
All right, bye.